my pants and twist my fingers with my hands. While all these rap niggas wanna be bloods, never see him in the hood, only see him in the...
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
So the first topic is going to be sequences and limits of sequences. So a sequence is something that it's just a set of numbers. So this is a sequence right here, like 1, 2, 3, 4, 5, 6, 7. This is also sequence pi, 3, 5, 102, so on. It's just any set of numbers. And the way we can get a number in a sequence is we talk about which term it is. So for example, in this sequence right here, we can call this the 0th term, we can call this the first term, call this the second term, third term. Same with this one, we can call this the 0th, or call this the 0th. This would be the third right here. This would be 4th, 5th, 6th. And you don't have to start from 0, you can start from 1. So we say that it's a sequence is a function of the form so we take natural numbers and we put in natural numbers and we get out a real number. So we can also, just like you can call a function like f of x. For sequences, we usually use the notation a sub n, with a sub 0 being the first term, a sub 1 being the next term, and so on. If you want to talk about the whole sequence, then we'll use these brackets. So if you want an example of a sequence, we can say a sub n equals -1 to the nth power, with n being 0, 1, 2, and so on. So we can say that the sequence equals -1 to the 0th power, which is 1, -1 to the first power, which is -1, -1 to the second power, which is 1, -1 to the third power, which is -1, and so on. Another example is a sub n equals n squared, with n equaling 0, 1, 2, and so on. So in this case, our a sub n equals 0, which is 0 squared, 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, and so on. So we can rewrite our sequence in a different way. So if we're given the sequence, say our sequence equals 1, 1/2, 1/3, 1/4, 1/5. We can find the pattern. We can write down the expression for the sequence. So for example, we can say a sub n equals 1 over n plus 1, where n is 0, 1, 2, and so on and so forth. So another thing we can do is if we want to change the starting point for our sequence, let's say we don't want to start at 0, we want to start at 1. If we do that, then we're moving one position to the right. If we do that, then we want to substitute n with n minus 1. So wherever we see an n minus 1 here, we're gonna replace it. Whenever we see n, we're gonna replace it with n minus 1. So you can also say a sub n equals 1 over n minus 1 plus 1, which is just 1 over n. And now we can say n is 1, 2, 3, 4, and so on. Now if we want to go the other way, let's say we want to start at negative 1 for some reason. We're moving to the left, then we substitute n with n plus 1. So we would have a sub n equals 1 over n plus 1, which is 1 over n plus 2, with n equaling negative 1, 0, 1, 2, 3, and so on. So we have another type, a specific type of sequence called a recursive sequence. And in recursive sequence, the next term in a sequence depends on the previous term. So, for example, we can have a sub n plus 1 equals a sub n times 2. So for first term, a0 is 1. Then a1 is going to be 1 times 2. a2 is going to be a1 times 2, which is just 2 times 2. And then so on and so forth. And as you can see, this gives us an exponential type of growth. So we could write this in its explicit form. So this is the recursive form. If you want to write this in its explicit form, it would be a sub n equals a0 times 2 to the second power. And we know a0 is 1. So a sub n equals 2 to the n, with n 0, 1, 2, 3, and so on. So this is called a first order recursive sequence, because it only depends on the term right before it. If it depended on a term that was 2 steps before it, then we'd call it a second order sequence.
In the ride, got 2 motherfuckers wanna fight me outside. Fight me outside, fight me outside. You should have seen how a nigga pulled up in the